Hello, Algebra 2. Chapter 2.4 is, as you can see here, about writing equations of lines. In that sense, it's a bit of the mirror opposite of Chapter 2.3. Back in Chapter 2.3 last lesson, we were talking about how to work toward finding, how to start with an equation and work from there to find something else. In this case, you're given information and you have to work toward figuring out what the equation is. So along the course of completing Chapter 2.4, you have to become proficient at 6 different things. I won't read all of these to you. You can always pause the video at any time you want and read things and write them down. But I do want to point out 2 things at least, and that is that steps 3 and 4 here, you've got to be able to do these things. You've got to be able to write these equations in these 2 different forms, and you've got to be able to do both. One form is slope-intercept, and the other is point-slope. And that's because each of these forms is useful at different times, and you've got to become comfortable in both cases. Step 1 of the things out of the 6 that I listed on the previous slide is to be able to look at a graph, see the line, and tell what the equation is. You build toward that from the slope-intercept form. It's the easiest form to use when you're looking at a line. So you should be familiar with this setup, y equals mx plus b. And in order to fill it in with more specifics, I need to know what that m is, what that slope is, and what that b is, what that y-intercept is. Well, first let's calculate m. Let's calculate slope. Notice that I'm going down 5 in order to go over 2 in order to move from one point that goes through crosshairs on the grid to another point that does. And so there, -5 over 2. Remember, slopes change in y over change in x. And b is simply where your graph crosses the y-axis. It's crossing it at -3. And that's your equation. It's as simple as that. So go ahead and do that, if you would, for these 2. Hit the pause button. Okay, I'm going to assume that you did that. The one on the left is the easier of the 2, even though it happens, or in my opinion, even though it happens to be crossing and finding its y-intercept between crosshairs. And here's that equation that I was expecting you would have written down. Now you might have written this as -0.5, you might have written this as -1.5, but you should have something like this, and you should not have this as 6/4, for example. You should be simplifying things down. The one on the right, the challenge there, and really the only challenge, is that you have to identify places where the line, the blue line, is going through crosshairs. If you don't, it becomes harder to identify slope and y-intercept. Well, I'm pretty comfortable saying that it goes through -1, but here it really doesn't look like it does. And in fact, it doesn't look to me, along the course of the whole blue line, like it ever precisely goes through crosshairs. So I will say that coming up with an equation when you're looking at a graph is a little bit of a judgment call. I ended up coming up with this. I ended up saying that the slope was 3 over 4. I felt like if I went up 3, I went up over basically 4. And I couldn't really be a whole lot more precise than that with the graph that I was given. Second step, and this is the easiest. You really have to be fast at this. Remember, if I give you the slope and I give you the y-intercept, well, we did teach you the slope-intercept method. So you simply fill in for m and b those numbers. So again, m4, b -4. I won't even bother having you practice one of those. I assume that you can do that. Instead, I'll move on to stage 3. You've got to be able to write an equation when you're told the slope and the coordinates of one point. And you've got to be able to do that, like I said before, in 2 different forms, point-slope and slope-intercept. I'm going to show you both. Here's the point that the line goes through, and here's the slope that it has. To write it in point-slope form, you've got to remember the setup for point-slope form. This is from Algebra 1. This is the general form of point-slope. And remember, the y1 and the x1 get filled in with the values from a point that the line goes through. Well, it goes through the coordinates 2, 1, and I filled those in here in red, and it also has this slope, -2, and I've plugged that in. That's it. That is the equation in point-slope form. If you want to turn it into slope-intercept form, one way to get there is to work from point-slope form first. Since point-slope form is so easy with this particular setup, when you're given a point and a slope, you can work from there. Simply distribute this -2 as I've done here. Move that -1 over to the other side, and you end up with this equation, y equals -2x plus 5, and that is your equation for this scenario in slope-intercept form. Now, there is the more traditional way to do this, and I'll show you that as well. If you want to go straight to slope-intercept form, and this is what the textbook will tell you. Of course, you're writing y equals mx plus b, that's what slope-intercept is. And you're going to fill in the information that you have. I know that y is 1, I know that m is -2, and I know that x is 2, but I don't know b. So that's what I have to solve for. Simplify that down, the -2 times 2 becomes -4, move that -4 over, and I've got b is 5. Now I put this, b is 5, back in to here, back into the generic equation. And I end up with this answer. -2, remember I was given -2 as my slope, and I put 5 in for b, and that's it. That's the answer if you want to go straight to slope-intercept form. If you want to rewind and check, you can see that that's actually the exact same answer that I got to by going a less traditional route, first giving you point slope and then going from there to slope-intercept. Again, your turn. Same thing. You've got a point, you've got a slope, figure it out in both forms. Okay, I'm going to assume that you paused and that you've done that. Here are those answers. I've highlighted them in yellow. Please note here that this top row here is not an acceptable answer to me. I don't want to see y minus -10. I want you to convert that to y plus 10, and likewise here. I want you to convert that to x plus 1. Notice that I've given you both forms. Okay, stage 4 in the progress through this chapter. You've got to be able to work with situations where I give you a point and I tell you that your line goes through that point, but it's perpendicular to this line. Well, remember, we talked about this briefly in the past. A perpendicular slope is the negative reciprocal of what you had. So if the line that you're working from has a slope of -3, then your slope is going to be positive, and it's going to be the reciprocal, so it's going to be positive 1/3. Now in point slope form, now that I've got the slope, all I've got to do is fill in that 3 and that 2, and that's what I've done here. There's that x minus 3, there's the y minus 2. That's done in point slope form. In slope intercept form, I take this same setup, I distribute that 1/3, and what I end up with now is 1/3 x minus 1. Now I move that 2 over, and I've got 1/3 x plus 1, and now I'm done. This is the equation in slope-intercept form. Each of these is a legitimate answer. This is the answer in point-slope form, but if I ask you to give it to me in slope-intercept form, that's the answer. Okay, what happens though if I ask you to do the same thing, but I tell you your new line is going to be parallel to this line? Well, now the slope is -3. I'm going to go a little more quickly through it now. I said the slope's -3, but otherwise it's the same setup as the previous slide. Doing this in slope-intercept form, again, I'm going to have to distribute that -3 across. So I'm going to end up with -3x plus 6 down here. And my final answer is going to be this one. This is my equation if I ask you to give it to me in slope-intercept form. Here it is up here in point-slope form. Please don't hesitate to come in and ask questions if you have them. But otherwise, it's your turn. Go ahead and do the same thing. Point-slope form here, from a point and this equation, and slope-intercept form. Keeping in mind, I'm only asking you one scenario here. Just give me the perpendicular. Okay, I'm going to assume that you hit the pause button. You've done the work. I'm simply going to show you the answers to these two scenarios. Here's the equation in point-slope form. Here's a matching equation. It's the same information, just written in a different form. This is the slope-intercept form. These two yellow equations are equations for the line that's perpendicular to this one and also goes through that point. Fifth scenario, if I give you 2 points, In this case, well, the more traditional way is definitely the preferred way by the textbook. So I'm going to show you the more traditional way, going straight from these points to the slope-intercept form. First thing I've got to figure out is what the slope is. Well, the slope is change in y over change in x. It's going to turn out to be 3 over 4. So again, it's going to be y equals mx plus b, so I go ahead and plug that 3/4 in. Now I'm going to put y and x values into that equation. I picked the 2 and the 4. I'd rather not deal with negatives. So now I've got everything I need, except I don't know what b is. So I'm going to solve for b. Multiply the 3/4 times the 2, I get 3/2. Move the 3/2 over, and I'm going to get b equals 2.5. Put this b together with what I had up here, like so, and I'm going to get an equation. Y equals 3/4 x plus 2.5. That's the equation in slope-intercept form, and that's a perfectly legitimate answer. There is a slightly faster way. If you want to do it in point-slope form, set it up this way. Use the coordinates of both points. Plug them in, right? So I've got y1 minus y2 here equals m times x1 minus x2. I've simply used both x's over here. Now I'm going to solve for m. And I'm going to find that m is 3/4. Notice it's the same as the slope I found over here, and it should be. Now that I've got slope, I can simply plug back in, one of these two coordinates into point-slope form. And this is a perfectly legitimate answer. But if I wanted, I could go forward like I did before and turn this form into slope-intercept form. I'm going to distribute the 3/4, then I'm going to move that 4 over, and notice I get the same answer on the left as I got on the right. Either way is fine with me. So here's an opportunity for you to try it. Hit the pause button. Okay, I'm going to assume that you did that. I'm just going to go straight to the answers. The right side's the more traditional route where you write it in slope-intercept form. The left side, the less traditional route, you've written it in point-slope form. And notice I've given you two different choices because you had two different sets of points to work from. Both of them had a negative, that they were both equally challenging. You might have written it this way, or you might have written it that way. Both are fine. Okay, the last thing. And it's possible that I'm going to have to carry over like 1 minute, unfortunately, to make this video fit. But direct variation is an important concept. On second thought, as I think about how much time I'm going to need to talk about direct variation, I don't want to rush through it. So I'm going to stop the video here, and I'll pick up with just this last idea, this sixth idea, in a very short continuation.